So yeah, a recent change to my presentation. I renamed it, so it's now called smbd Quo Vadis. And so my name is Böhme. I'm a member of the Samba team since many years, and I work for Cernet. And in this presentation, I'm planning to give an overview, basically of what's up our sleeves. All the stuff that has been in work in progress, being worked on by team members in the past 5 years, maybe, but that isn't yet finished and released. That's going to be the main part of the presentation. I'll start with just a brief recap of recent changes in smbd, so as to say in the file server. And luckily, thanks, John, for your excellent presentation and this outlook into the future of where Samba is hopefully going to thrive in the next years. So looking into cloud and Kubernetes and all that stuff. You did this all for me, so I'm going to skip this, all that stuff in my presentation. I expect this, so I really try to give a condensed and hopefully complete overview, but I'm pretty sure I've missed a few things that we have maybe achieved in recent months or in the last year, or stuff that it is being worked on by folks and our community. Sorry if I missed something, your favorite feature. Just let me know what you're working on, and I will make sure to include that in my presentation for the next year. All right. So, having let that out, let's move on to a brief recap of what we maybe got from changes from the last year. And I would again like to highlight and start with this big change that we had in the last years, a lot of work that went into there, and that then resulted in the release 4.15, which fixed the infamous symlink array security issues that we had, CVE number 2021 something. And this was all fixed basically as part of the Samba 4.15 release. And it was, to get there, it was really a large task. We had to convert the whole Samba virtual file system layer and convert all path-based calls to handle-based or add-based calls. So, for example, I'm giving an example here for doing fstat or fstat add instead of stat, and then of course rinse and repeat for all the other syscalls. So it was a lot of work, and we had a few interesting lessons learned. One of them, dealing with symlinks safely is a huge problem. And there will be entertaining and interesting talks on this topic, I think today from Volker and probably tomorrow from Germany. So make sure to watch those. They will highlight that symlinks are a real pain in the ass to deal with. And then, of course, we just noticed in recent weeks or maybe months that the changes for the symlink race problems caused a performance regression in the file server. So we are getting slower, and nobody likes getting slower. And Volker has a presentation on that end. Make sure to don't miss that one, because that's the one that's going also to be interesting. More on that a little bit later also. I think I have more on that on a later slide. So next on our list is we have a new RPC infrastructure. I've taken a screenshot here, so this is actually not text. This is a screenshot taken after starting Samba and listing shares. And what we see here, we have an additional, not clicking, see here. Okay, we have an additional process, Samba-DCE RPC daemon. That's the new kid in town. RPC server now runs in its own process. Previously, RPC services were basically run as part of the smbd binary, and this has all been completely refactored, and RPC services are now running in a separate binary that is by default started automatically on demand when RPC requests come in. And smbd or others that make use of RPC just pass over blobs over local pipe back and forth between the process and Samba DCE RPC daemon. And this allows running this. So this allows doing interesting things. For example, this would allow just running the RPC server and using it with any other SMB server, not Samba. Like, for example, eventually in the future using the kernel KSMBD. There's an excellent summary on this feature in the 4.16 release notes, so take a look at that if you want to see more details about that. And a big thanks and kudos to Volker, who did all the work on this. This was a really tremendous and very well done and executed change. Continuing on. So this is a small slide, but I think this is pretty important. So this is a change I'd like to highlight. We have a new option to basically build our file server completely without the code for the SMB1 server. So we have a new configure option. By default, we keep building SMBD, our file server, with SMB1 support, but you can pass without SMB1 server to drop it completely from the binary. And thanks a lot to Jeremy and David's Samba team members who worked on this in the last month. This is really nice and a great way forward into the future. And now here's a kind of a kitchen sink of other changes that I was able to collect onto a slide here for you to take a look at, that have been done in maybe in the last 12 months, other noteworthy changes. And so starting with, we now have a merged RPC server infrastructure common between source 3 and source 4. This should allow us in the future to finally implement the witness RPC service, which requires async RPC support from the RPC server, which we previously didn't have in the file server RPC server. So looking forward for improvements there, hopefully in the future. Then SMB3 multi-channel is no longer experimental, thanks to a lot of tedious work, mostly by Stefan, fixing all the nasty corner cases, finding the corner cases and fixing bugs, and really torturing Windows behavior here with multi-channel failover for certain strange cases. And he really nailed it here. And then we were finally able to declare a few known bugs as fixed and declare multi-channel support as no longer being experimental. Woohoo! Then in recent months, a few folks worked very hard, as far as I can tell, on updating our internal copy of the Heimdall Kerberos, and which, well, I was only really able to come up with one actual feature that adds, and that's Kerberos fast support, as far as I can tell. So, but I'm not a Kerberos expert. Let me know if there are other important features this allows us. But all I know is this has been some real big chunk of work, and thanks to Andrew and Stefan, and I think Douglas also worked on this. In case I miss anyone, I'm sorry, but thanks to all of you. I think this was really a lot of work. Then I noticed we have support for certificate auto-enrollments for member service. Being, as far as I can tell, I'm not an expert here, being GPO managed and getting certificates automatically downloaded and installed at Samba servers that are members of a domain. Something like that, probably. Next is also a minor tweak, but a very important one. Trusted domains are no longer scanned by Winbind when Winbind starts. This has been changed. I think we've done that already in 4.15, or eventually it was 4.16. So this is a really subtle but important way forward to ensure Samba and especially Winbind operates in more complex Active Directory domain setups, behaves in the same way, essentially like any Windows system that is joined to a domain and doesn't do strange things like trying to talk to domain controllers in trusted domains that are behind a one-way trust and stuff like that. And finally on my list here is support for offline domain join. We've briefly touched this in John's talk. Yeah, this so it seems that there's an issue with using it, but I guess in best Samba tradition, we can improve incrementally on that, I would say, right? All right, so that is that. That was the view back. Now let's look forward. What's up our sleeves? And I've kind of split this in 3 parts, and I call that something features that are in a sort of work in progress, where I am aware that at least one Samba team member is actually working on this actively, and we have some funding, and I expect that this is something that we can expect to be completed in a reasonable time. And I mean, I have 2 items on that list, and the second is smbd3 Unix extensions. I basically put that there because I noticed some activity on a merge request with a work in progress code for smbd3 Unix extensions being done last week, I think by David Mulder. And I tried to get a hold of him, asking what's the status here. Is he picking up the work? Is he starting to work on this feature? But I didn't get a response, so maybe David can chime in later in Q&A and let us know if this is something that he's working on now. Which would be great, of course. I mean, because smbd3 Unix extensions, I think just another thing that John just mentioned that would be something good to have, even in the cloud and Kubernetes world. So I have more on that, a few more details on a later slide, a few more rounds, but yeah, get the basic idea. And then I have a longer list of prototypes. Like all the important smbd3 features like directory releases and persistent handles that we don't ship in Samba product releases yet, but instead we still have work in progress branches scattered all over the world in the public Git repositories or in private repositories on someone's laptop. As far as I'm aware, this is mostly stuff that is not really actively worked on, but more on that while I go over each item and give you a brief overview over each feature. And then at the end, there are a few things I would like to point out where we are basically still at the design phase, but those are probably interesting things to briefly look at and maybe bring up everyone's attention to those things. So now let's start with the work in progress ones. And so the first one is the file server performance regression that I mentioned initially. So this is basically affecting releases starting with 4.14. Currently we are at 4.16, so 4.14 and anything newer is affected by this. And its most dominant effect is on metadata heavy workloads. So clients that are hammering the server, opening and closing files a lot and copying small files and workloads like that. Basically, opening a file handle on Samba file server has become more expensive. We are doing more syscalls. But I would like to defer details to Volker's presentation here. One thing that I would like to point out here is highlighted here in orange, and this, to me, this seemed a bit surprising, but that's just the way our code works here. We have an option in Samba actually that tells white links yes. That would tell Samba, well, ignore security. If there is a symlink configured to etc passwd, just follow it and just return info for etc passwd if there's a symlink for that, and the user explicitly requested white links enabled. But it turns out that doesn't even fix the performance problem, because we're still doing the checks, and after doing the expensive checks, we're determining, okay, this is a link that points outside of a share. Then we check the option, white links yes, and if it's set, then we allow access. There's some decent amount of work to be done to get all this fixed, and to point out one thing at the end, this is probably very file system dependent. So I expect on file system like cluster.fs or FuseBed file systems, the performance impact is probably going to be much worse than what we have when just doing some benchmarks here on a local file system. So I just did some quick test here, doing rsync of an extracted Samba table to an smbd3 mount. Server is just Samba here, mounted with the Linux kernel client, and then just comparing the different versions and taking 4.13 as a baseline. You see that 4.15 and 4.16 is a little bit slower, and this is on butterfs. And as I said, I expect this to be the impact going to be much worse on virtual file systems behind the DFS module or fuse-based ones. And now in master, we are kind of back to what we had in 4.13, but this is only part of the story, it seems. So I'm going to quit here basically and defer to Volker's presentation. He's going to go into a lot more detail in all of this. Some work is being done here. As you see, that's master. We already got some improvements back. But this is probably not all. There are still performance degradations. So I really strongly encourage participation of vendors and distros, and of course users here to help us improve again. And for details, please check out Volker's talk. So I'm at slide 8 from 32. Let me check time. I'm 20 minutes in, I guess. So basically half the time. So yeah, I gotta hurry up a little bit, I guess. So smbd3 Unix extensions, briefly mentioned that before. It would be really good to get those. We have some WIT branches, as far as I know, from Jeremy, and I think Volker also worked a little bit here on probably on the client side libraries, as far as I remember. I'm not sure. And I mean, I think I have this on the next slide here. And yeah, for me, kind of takeaway for smbd3 Unix extensions where I see this is really to conquer the data center, persistent storage for containers and cloud infrastructure, right? And basically really being the one-stop solution for Linux to Linux file sharing, right? And as far as I can tell, we are not so far away from having this. Maybe it's kind of a low-hanging fruit compared to other features that I come to next. Maybe, hopefully, ideally, I don't know, maybe just a few weeks of work and not months in development effort. But unfortunately, currently, there's not too much really user or vendor or distro interest in this. So I kind of expect slow progress on this. Oh, I don't know. I mean, the question would be up to David Mulder. If he's here, please chime in, or maybe we can have a Q&A at the end. Whatever, I don't know. Yeah, so...
so, Ralph, Jeremy here. You're right. The main problem is the symlink handling inside file name convert, which means changes to the core path name processing. And then we also need to add the testing to libsmb client and SMB client, so that the tests that we currently have with SMB1 keep working, or at least we modify them so that they make sense with the SMB3 POSIX extensions.
Yeah, I get that. Yeah, I had that on the previous slides. I kind of skipped over it because it's really a subtle internal detail. Yeah, I mean, we're basically kind of agonizing there because I know there are different approaches how we could do that, but that's basically just an implementation detail, something that we have to do. So I think, yeah, we'll see. Maybe we can get this year. Fingers crossed. So let's move on to the prototype. So this is a very long list of stuff that has been worked on in the last years by various folks, starting here with IUUring, which is a kind of Stefan's favorite pet. And so Samba already has support for IUUring with a VFS module. And the interesting thing here that's missing is that currently the VFS module still uses traditional p-read and p-write for doing the I/O, which involves expensive memory copies. So expensive, at least when you get to the I have this here in the middle of the slides. If you want to get to the 35 gigabyte per second range on a system, and I mean, I think so. This was measured here, 35 gigabytes per second, just on my laptop, with including those changes by Metze, which are integrating support for splice and send message into the VFS IUUring module, which gets us rid of all the expensive memory copying. Not completely, as far as I remember. I think in one of the I/O directions, copying is still done probably, but that could be improved in the kernel or something like that was a takeaway. But at least with this prototype, Metze and I, we were able to get really impressive numbers. I mean, just measuring here over loopback on my Dell XPS 13 laptop from, that is, I don't know, 4 years old or something like that. And I got something like 35 gigabytes per second with aggregated over 5 connections from 5 clients. So really impressive. And at the same time, I don't quite remember what was the bottleneck, but I think it was it still the clients? We weren't able to get enough clients really hammering the server. I mean, and also server and clients were running on the same system. So on some decent hardware, we could do better probably. And this is certainly probably something like 3 or 4 times at least. I don't remember exactly the number you can get here with these changes compared to the currently shipping IUUring VFS module. That's at least roughly what I have in memory. I mean, I might get the detail a little bit wrong here, but you get the idea. It's really a huge improvement. Yeah. So takeaway. Yeah, really for me, this is something that we should get as soon as possible here for enterprise file servers where you have where you want to really do a lot of I/O, and it's kind of a low-hanging fruit. So I don't think there's too much work needed here. Maybe a few weeks, but unfortunately, currently no one is really funding this or users testing or anyone working with the Samba community on this. So this would help a lot really to get this upstream soon. So next on my list, and I probably got to hurry up even more. So next is locking TDB split up. So this is something for a use case for clustered Samba. So suppose you have many clients open the same file on different Samba cluster nodes. For example, like you have really 10,000 clients, and then early in the morning, 9 a.m., they all come in and connect to the server, and then they all end up opening a single file on the server. And this might be something like an application phone book exe that all folks in the company are using for storing and retrieving phone numbers or stuff like that. And this puts some interesting load on the server. And we fixed some of the problems in the past. So thanks, I think Volker did this. What is here highlighted in this pass. This is basically a change in how we marshal all the open file related state in our login TDB database. And this is already included in Samba since a few releases. And that helped a lot for workloads where you're getting just subsequent opens on a single file, thousands, but eventually not on clustered Samba, but just sequentially, even with some delay. But in older versions, this started to get really, really slow due to the MDR decoding of all that information in the TDB database record. So, and one problem remains here really for clustered Samba, and that is that all those 10,000 users coming in at the same time result in an interesting problem, and that is that the records in CDDB keeps bouncing across nodes. So that's at least my understanding of the problem here, which requires another subtle change to our database model here, which I briefly try to discuss here. And the high-level idea is to split up login TDB records to store the file open entries locally per node, and then use an additional record that just stores a superset of those share modes, of those open file related Windows FSA state. And the expectation is that this record then becomes more or less stable and doesn't change anymore really, which makes it a good candidate for CDDB read-only records. And this would then fix the problem of this record being bouncing across the node and no one really being able to accessing the file because SMBDs can't get a hold of the record. So, I mean, this is probably kind of a big effort for a special case, it might seem, but I would take it one step further and say that the resulting semantics that this would give us really may turn out to be and make a lot more sense compared to what we currently have. And there's some notable vendor interest in this to get this special problem fixed. So there's likely work going to continue in this area, and eventually we should move into that direction in the near future. So going on to SMB3 directory releases. So just maybe very briefly, what are directory releases? That gives clients the possibility to cache directory contents, right? So the client then doesn't have to ask the server again and again and again, please give me the directory listing. It just caches it. And then, of course, if you're caching something, you want to make sure that you don't end up missing changes that are being done by other clients on the server. So the previous solution, 50 minutes left, yeah, thanks, has been based on change notifications, which is kind of a best effort. And with directory releases, this turns then into really a reliable cache. And so this takes the idea a whole step further for allowing the client to cache directory contents. And I've been digging hard in SDC presentations from roughly 10 years ago or even older to find some slides from Microsoft where they gave presentations on this feature at SDC. They gave some numbers for different workloads or about how much directory releases help for certain workloads. And I mean, obviously for something like a home folder workload where you don't have concurrent access to certain directories, you just have a single user that is accessing that, you can basically expect a 100% packet reduction for that. But of course, the effectiveness depends on workload. And the fewer changes by other clients are done, to the cache directory, of course, the better the caching. So I'm kindly reproducing here without permissions some numbers, but I took it one step further, and actually I just took the numbers and made my own graph. So hopefully this is okay. So this is from STC 2010, and gives some numbers for reduction of packets for the mentioned home directory workload. So I mean, you see here for query directory on the right, it goes from 97 to 0. I mean, probably 1 at the beginning, right? But yeah, then that's it. And for the other SMB requests, like change notify create, you get some decent reduction, but the effectiveness then, of course, depends on the actual workload. And there's another graph here that adds a few more numbers here for different, I think those are FSCT scenarios here. And you get the idea. Directory releases probably, depending on the workload, help a lot. So this would be really something that would be to get included in Samba. And the status here is that we have a basic functional prototype. Not all implement operations that must trigger a cache eviction on the client are really fully implemented then. There are a few that are missed out in the prototype, but this is just yeah, some gaps that have to be filled in. I think as far as I remember, this already passes the Windows protocol test suite, so good on that end. But of course, we need a lot of CI tests for our own CI. So this is not a too large feature. It's a reasonable patch set, but I would say that completion here depends on funding. I haven't been able to really work on this to get this upstream. We have a prototype, so hopefully we can get there over the next year or something. Which brings us to the next one, smbd3 persistent handles. I think I'm starting to skip a bit here on the descriptions on the feature itself. You can come back to the slides and read about it in case you really don't know what it is about. But I mean, if you're interested in this, you're probably aware what the use case is here. And so for persistent handles, we have a basic prototype as well. So it implements the smbd3 front end, and that's basically the easy part. It implements quite complex changes at the database layer in Samba, where we store the file handle information. It has some CI tests. It's quite a largish patch set. I think something like 140 patches when I counted them last time. It's in bad need of being rebased on current master, and I mean, so I don't expect serious conflicts. I know there are serious conflicts because of the mentioned changes that we had. Well, not really, other changes actually, but anyway, those cause conflicts, but that's just the way Samba development works, right? But these changes here are not so easy to fix, so that's something that has to be done. And of course, there's still a lot is missing from this. So this is just a really very basic prototype with very sharp edges that you can cut yourself badly. So don't use that in production. I gave a Samba presentation. I gave a presentation on this at sambaXP in 2018. In case if you want to know any more details. This has shown little interest from vendors or distros. So without a lot of more funding here, I don't expect more progress because this is really complex. I vaguely remember that Samuel picked up work on this 1 or 2 years ago. I think we probably then got distracted working on DC RPC server or something like that. Maybe I should put it that way, but yeah, I don't know. Maybe someone else is working on it that I'm not aware of. We'll see. Which brings us to witness service. I just included this, I think this morning when I noticed that. Oh, I missed that when I put together the slide for the async RPC server that we now got in thanks to the work from Samuel. So we have a prototype done by Günther Deschner here for the Witness RPC service, which is kind of related to the larger continuous availability feature here, talking about before, like persistent handles and so on.
If I quickly may chime in, I think this got superseded by the work from Samuel as well. I think he also has a prototype. I'm pretty sure, and I think it's more advanced than ours, which we did back then on top of the Samba 4 async RPC server infrastructure.
So Samuel did a rewrite, or did he pick up your code?
No, I think the infrastructure has changed so much that he really kind of started from scratch.
So. All right, okay. So, I mean, I would love to have Samuel now chime in here and give a brief introduction, but I think I have to move on. I only have something like 7 or 8 minutes left, and still a few slides to go. So yeah, I mean, anyone interested in discussing this, maybe we can use the chat after the presentation is over. So this brings us to SMB Direct. This is something also Stefan Metzmacher, my colleague, has been working on a lot in the past. So SMB Direct, file storage for the enterprise, minimal CPU utilization, very low latency. But as you're reusing the existing hardware infrastructure, it's ease of use, flexible choice of converged network, having RDMA and TCP/IP running on the same network, and so lower cost of networking infrastructure. So SMB Direct is basically similar to TCP, but it just runs over RDMA. And so this RDMA basically makes DMA possible over networks for remote peers and completely bypasses the operating system and its protocol stack. So it doesn't require any CPU interaction in order to do the actual transfer. And so Stefan has been working on this since many, many years as kind of a side project, and he really got very, very far. So he actually went ahead and wrote a functional Linux kernel module prototype that is decently functional. I would say probably a lot of sharp edges and a lot to do, but it works for basic testing, which is a huge achievement. And so the whole thing is several parts. So there's the kernel module. We have a user space API, so which actually allows smbd, our file server, to make use of RDMA and SMB Direct, hooking up and connecting to the kernel module, which does then the underlying RDMA access. And then we have not so big changes to the SMB file server and the core client libraries and so on. So all in all, it's a big change. And there's a lot to do, like coordinating with Linux kernel developers on the right way to expose this API that a user space process like smbd can use when connecting to the kernel module that does the real RDMA in the end. The code is still immature, so much time really is needed to get this to production ready. We need trace points, we need a standalone test suite, multi-channel integration seems not to be really finished yet. We need integration into Samba CI for testing, and much more. For details, see Stefan's presentation here from STC from 2018. Very interesting talk. There's a lot more details. So expect several months of development is still needed here. So this definitely needs funding to get this, to move this along, right? Which brings us to S4U to self. Quickly skipping over this in order to try to squeeze all the rest into 5 minutes. So what is S4U to self? That's a replacement. So that's a mechanism that Winbind could use a Kerberos mechanism to reliably get group information for users. Typically on a Samba file server, Samba gets the group information for a user via the so-called PAC, either via NTLM authentication or Kerberos authentication. So typically, as for you to self in a simple SMB file server scenario where you're using the file server is joined to a domain and Windows domain users are accessing the file server, there's no real need for this feature. But once you have scenarios like SSH access to the system or sudo or, for example, NFS3 access to the server, and you have Winbind configured as the user and group provider and switch for the system, then Winbind eventually doesn't have those authorization data for the user, and Winbind needs some way to figure that out. And there's one way that is using the token groups from LDAP, but that doesn't work reliably in certain scenarios. And the only way to get this done reliably is using S4U to self. So, yeah, I think pretty much covered that. It's let's say it's complex. It involves it needs so the Kerberos libraries, MIT and Heimdall, are missing features that we would need to get this integration in Samba and Winbind. So we would need to work with the Kerberos, MIT and Heimdall communities here to get missing features. So this is something like a really complex task to get this done. Stefan gave a presentation on this 2 years ago, sambaXP. That gives a good introduction into all the tricky bits that are involved here. So the key takeaway for me here is so this is probably not really needed for your simple SMB3 NAS box where you just have Active Directory domain users accessing the system, right? And it's probably going to be a complex and tedious because I've got to work with Heimdall and MIT here to get the missing Kerberos features. And so, summary, probably something like several months of complex coordination and development needed. All right, which brings us closer to the end. A few things that are basically just ideas being kicked around. This is something that I have been thinking about in the last months for improving basically file server performance, and this has been something that has been plaguing our vendors in the last years, mostly the ones that are using Fuse-based file system or stuff like that. While doing ex-ata requests is expensive, and Samba by default does a lot of extended attributes requests in order to read and write possibly the DOS attributes. We're storing that in an extended attribute, and we're basically querying that all of the time when user is accessing a file, when listing directories also. And so a few years ago, we already provided some kind of solution for this by making at least the code path when clients are listing a directory, parallelizing the ex-ata processing with the pthread pool in the background. But as far as I remember, customers were basically complaining that the load is still too high. That was, I think, feedback we got early this year, which started some brainstorming and discussion. How could we improve this? And so the basic idea that I had that we could get away for most of the files without actually needing to store the DOS attributes ex-ata. And that would involve using the native Linux birth time available via statx and the statx ata no dump attributes for the Windows archive bit. So the prerequisite here would be to add support for statx in Samba and plump this through, and then doing some kind of on-the-fly conversion for existing DOS attributes, X address, and this would likely then get rid of most extended attributes in the file system that just have archive attribute set and the creation date when a file is created on the server by a Windows client. So another one. So yeah, this is just to put this out here and mentioned are the new kit on block here. ksmbd has been presented a few times already on past sambaXPs. The new kernel smbd file server in the Linux kernel. And so now that we have the Samba DC RPCD infrastructure, this will make it much easier, for example, to optionally use the ksmbd file server as a replacement for smbd, if there's a use for that. I mean, so ksmbd is still missing a lot of features. You can use it as a basic file server currently. It's pretty functional probably, but some important stuff is still missing. For example, currently I don't think it has support for being joined to domain. And one possible way to get there would be to let a WinBind do all the work and Samba DC RPCD in user space, and ksmbd would just connect from kernel to user space. And let Samba DC RPCD do all the RPC work, and WinBind do all the domain join work and so on. So this is just an outlook in the future here, requiring a lot of research and development then in the future. So I have two more to go. One is SMB and NFS interop. I mean, this is something that keeps coming up every year. In the last 10 years, it's also something that Volker keeps running into when talking to customers, and others probably are also aware of that. This what we currently have on Linux is not ideal. It is lacking. We have some kind of support from the Linux kernel for oplogs and leases, and share modes recently has had to be dropped. So the problem is then if files are accessed by any other means than Samba and SMB, for example, by NFS or local SSH access, if there's allowed, or FTP or whatever, and you have a file where you're allowing caching by clients, so you have oplogs or leases granted, what happens? You get data corruption. If you don't have proper Linux kernel support where Samba can work, gets notified by the Linux kernel that another process is accessing a file, right? And we have an API here in Linux, but that only works for exclusive oplogs. It doesn't work for shared oplogs. It doesn't work for leases at all. And continuing on to share modes, this had been available in the Linux kernel and used by Samba for a long time, but now it turned out that we've been notified that, this is basically broken for a long time. It really doesn't make sense to integrate with that. So we just recently dropped support for this, for using the Linux kernel API. So we have a VFS hook remaining. So VFS modules can still hook into this, and for example, GPFS still uses that because GPFS has a file system specific API library call that they can use, that they offer for us to integrate into their file system, right? But for everything else, it's currently not working. So yeah, that would be a lot of research and brainstorming coordination you would need with the Linux kernel community to discuss and design new APIs that would help us, that would also eventually help NFS Ganesha and maybe others. So, which brings me to the last slide.
So, Ralph, I have to interrupt you. We are 5 minutes over the time. I'm sorry. And
here you go. So this is poor Martin standing here in the middle of the labyrinth, and so I'm not going to cover this. I defer to Martin's talk that he's going to give tomorrow at 4 p.m. All right. So That's basically it. I have a few links. So probably no time for Q&A. That's it. Thanks a lot. And sorry for taking too long.